Nabila binti Abdullah Halim. I am a student of Science Mathematical in UiTM Johor.
Hi and Assalamualaikum guys. Today I want to talk about our geometry project and my group called SEGAMAT. Our members is me, Nabila binti Abdullah Halim. Second is Rajin Atira binti Rajimo Farid.
Hi, Assalamualaikum. My name is Rajin Atira binti Rajimo Farid and I'm a student of Mathematical Science in UiTM Johor campus SEGAMAT.
And third is
Hi, my name is Alia and I'm a mathematical science student.
First of all, I want to share with you the introduction of geometry. What is geometry? Geometry is a Greek word consists of geos means earth and metron means measure, which means earth measuring. In fashion, the Egyptian, the Romans and the Greeks used geometry in the world of architectural construction. It was used to solve most problems from building construction to astronomy. First project. Our first project is bed frame. Do you know bed frame? Yes, this is our first case for our project. Do you know how to measure the bed frame? We show you. So let's calculate the measure of the bed frame.
This is the bed frame that we want to measure.
Here is his story about bed frame. Do you know the history about bed frame? Bed frame or a bed stead is a part of the bed used to position the mattress and base as a foundation. It may include means of supporting a canopy above. Bed frames are typically made of wood or metal. A bed frame includes head, foot, and side rails. It may also include stilts to support the mattress, in which case a separate base is not necessary, as in a platform bed. Most double full-size beds, along with all queen and king-size beds, required some type of center support rail, typically also with extra feet extending down to the floor. The term bed frame was first used in 1805 to 1815.
So, as my friend mentioned just now, this is our first case, and as you can see on the slide right now is the measurement of the bed frame. So as you can see, the bed frame is a combination of these three shapes, and you can see the cylinder shape at the leg of bed frame, rectangle shape on the body of the bed frame, and the semicircle shape at the head of the bed frame with the calculation of the area. So the first one is head cylinder. The formula is 2 pi r head plus r, and the calculation is 2 times 22 per 7 times 2 open bracket 240 plus 2, and the answer is 1521.143 centimeter square. For the body frame, since the body frame shape is rectangle, so the common formula is width times length. So the calculation is 198.5 times 96, and the answer is 19,056 centimeter square. Next is the leg at the body. So as we can see at the body of the bed frame, there are 6 cylinders, and this formula is the cylinder at the center of the body frame. So the formula is same as the head cylinder, which is 2 pi r h plus r. And the calculation is 2 times 22 per 7 times 1 open bracket 24 plus 1. Since we have 2 cylinders at the center of the body, so we multiply it by 2, and the answer is 314.286 centimeter square. For the leg frame, we separate it into 2 parts, which is the first part is the leg, which is 2 times 22 per 7 times 2 open bracket 47 plus 2. So we have 2 cylinders, 2 legs, so we multiply it with 2. And this one to 2 times 22 per 7 times 2, 96 plus 2. This calculation is the cylinder above the leg. Okay, so the answer is 2464 centimeters square. So the total area for all of this area, we add all of these answers, and the final answer that we get is 23,355.429 centimeters square.
So how to calculate the volume of the bed frame is for head cylinder by using formula pi r square h equal to 22/7 times 2 square times 240 equal to 3017.143 cm cube. For its body frame, 198.5 times 96 times 3 equal to 57168 cm cube. For its leg at the body, which is using cylinder formula pi r square h equal to 22/7 times 1 square times 24 equal to 75.429, and times 2 because have 2 leg at the body, so equal to 150.857. For its leg frame, which is have 2 cylinder at the vertical side and 1 at the horizontal, so 2 times 22/7 times 2 squared times 47 plus 22/7 times 2 squared times 96 equal to, the total is 2388.571 cm cube. So the total volume is 62724.571 cm cube.
Okay, so now for our second case for our project is shelf that sell at IKEA, and the name of the shelf is Harvana. Now I will talk about the history of this shelf. So since this shelf has wheels, so I will call it as trolley. Some say that the trolley concept was first developed by Charles J. Van Depot, who immigrated to the USA from Belgium in 1869. He developed a trolley car power system that operated a short rail line at the Chicago Industrial Exposition in the years 1882 until 1883. This shelf or trolley is a table on 4 small wheels with 1 or more shelves under it, used for serving food.
So here is a shelf trolley measurement, which is for each rack. The length is 48 cm, the width is 26 cm, and the height is 6 cm. For this trolley, the height for this trolley is 77 cm, and the length of the side view is 24 cm. Application of geometry that involved in these types of design is architecture. This is because architecture is a symbol of civilization as the product of physical structured buildings. So for our case, the application of geometry that involved for our case is cylinder and cuboid. So how to calculate the surface area for cylinder is lateral face area plus sum of base area, while how to calculate its volume is base area times height. To calculate the area of cuboid, which is width times its length, and for to calculate its volume, it's width times length times height.
Mathematical calculation for our second case. Okay, first of all, we have to measure the area of this trolley. What we can see here, we got 3 racks of cuboid shape, but for area, we have to measure the rectangle shape only. Okay, so we have 3 views from here. First from the side area and from the side view. Second is from the upper view, and third is from the front view. First, we have to measure this side. So 24 times to 6 cm. So we got 144, and we have to times 2 because we got 2 sides here. So when we times 2, we got 288, and because of 2 racks, so we have to times 3, and we got 864 cm square. Okay, second is for the upper view. Okay, for the upper view, the the length is 48 and the height is 24. So we have 2 times 8. 24 times 248, we got 1152. So we have 2 sides here, so we have to times 2 and we got 2304. So because of we have 3 racks, so we got 6912. Next, for the front view, the length is 48 cm and the height is 6 cm. So when we times it, when we multiply it, so we got 288 cm squared. So they have 2 sides here, so we got 576 because of we got 3 view here, so we got 1728 cm. Okay, now we have to measure the area of the cylinder. If we can see, this is the cylinder. Okay, for this high, this long cylinder, the formula to measure the area of cylinder is 2 pi r squared plus 2 pi r h. Here we can see the cylinder, the r of the cylinder is 0.75, the height is 77. So we can conclude that 2 times pi times 0.75 squared plus 2 times pi times 0.75 times 275. So the total is 366.536 cm squared. So here we have 4 same cylinder, alright? So we have to times 4 and the total is 1466.144. For the weight, for these 2 cylinder here, we can conclude, we can use the same formula for this cylinder. So when we measure that, we can get 126.107 cm squared. So we have 2 cylinder here, so we have to times 2 and we can get 252.214. Okay, done with the cylinder, we can move on to the wheel. You can see the trolley have 4 wheels on it. Okay, the formula is still same too because shape of wheel is a cylinder. Okay, so we want to measure the area of the wheel, so we're gonna use the same formula and 2 times pi times 1.75 because the radius of the wheel is 1.75 plus 2 times pi times 1.75 times to 3.5. So we can get 57.75 times to 4 wheel because we have 4 wheel here, and the answer is 231. Alright, now we can get the total area of this trolley. Okay, first of all is this is what we got from before. We just add all the total and we can get 11,453.358 cm. Thank you. Okay, we gotta move on to the next step. We have to measure the volume of this trolley. First of all, if you can see, we have 3 racks with shaped cuboid here. So if you want to measure the volume of cuboid, we have to multiply the length, the height, and the depth. Okay, so for these racks, the length is 48 cm, the height is 6 cm, and the depth is 24 cm. So we're gonna get 6,912 cm. 6,912. So we're gonna times to 3 racks. So we're gonna get 20,736. Okay, we're gonna move on to the cylinder. Okay, we have 4 cylinder here. 4 cylinder here. So the formula to measure the volume of cylinder is pi times 2r squared times 2 height. Okay, for this cylinder, pi times to the r is 0.75 squared time to 77 because the height is 77, and we have to time to 4 because we have 4 cylinder here. So the answer is 544.5 cm. Okay, for these two cylinders, we have to measure the same way with this cylinder, but we have to change the height because the length is not the same. Okay, for this, the pi time to r, the r is 0.75 squared time to 26 because the height is 26. So we're gonna times 2 because we have 2 cylinder here, and the answer is 91.928. Okay, for the wheel is also cylinder, right? So the formula is the same, pi times r squared times h. So we have 4 wheels. So the answer is 134.752. So for the total, we have to substitute all of the total. So this is for the rack, and this is for the cylinder, and this is for the cylinder, and this is for the wheel. So the answer is 21,507.18.
Is our part of our conclusion. Geometry is a branch of mathematics that studies the shapes, positions, and dimensions of things. In modern times, geometric concepts have been generalized to a high level of abstraction and complexity and have been subjected. People must open their eyes and change their assumption toward geometry. This must be seen quite hard, but it is easy to understand because all around has a connection with mathematical calculation.
Thank you for watching, guys. Bye.